today's class. For today's learning purpose, we'll be talking about packed cell volume. Packed cell volume. I want to thank all those that have been subscribing to our channel. I want to thank all those that have been sharing our videos for other students to learn from. And I want to encourage you that have not subscribed. It doesn't bite. Why not click on the subscribe button and turn on the notification bell so you'll be the first to learn or to know when another educative video is being posted. And I bless and I pray God bless you even as you subscribe. So what is packed cell volume? Now, packed cell volume is used in the estimation of the blood level in a human's body. Now, when you want to know the quantity of blood you have in your system, or want to know if you have enough blood or if you don't have enough blood, you carry out a test known as packed cell volume. Now, what happens is we use the technique of centrifugal force to separate blood into different segments to give you the percentage of blood present in your system. While we use a sample, we're not going to get the whole blood in your system to know. So because we cannot remove the whole blood in your system to check if it's enough, we get a small sample from you, maybe 2 mils, and then we analyze to check for the level of blood you have in your system. Now, patients with abnormally shaped red blood cell will have discrepancy or funny looking packed cell volume, like those who are sickled. Who have sickled cells, that's their red blood cell in the form of sickle, like patients suffering from anemia, sickle cell anemia, that's they have the SS genotype. Now you find that their red blood cells are sickled, and to make their PCV to be low because of the nature of the red blood cell, and because they are always undergoing destruction, their red blood cells are undergoing constant destruction because it's looking abnormal. So we want to know what's the level of individual blood level. It's important because blood supplies energy and oxygen to different organs of the body. So if there is not enough blood in your system, you might be having symptoms like dizziness. That is in cases of anemia. When you say anemia means that you have low blood level. That the blood in the system is not enough. So you're feeling dizzy, easily fatigued, weak. So those are symptoms of anemia. So we want to know, because it is dangerous for your blood to go below normal range. It can kill a person. So it's important. This test is one of the most important tests in hematology department. So in packed cell volume, we read the result in percentage or liter per liter. Now what we use, it's not difficult. We have a capillary tube. These are capillary tube. These are a capillary tube that contains anti-coagulants. These are blood, these are plasticine, these are haematocrit reader. So what happens is you get your capillary tube. Like I always say, mix your blood very well. Now, if you don't mix your blood properly and you are doing packed cell volume, if you leave blood standing for a while, the blood will separate into different parts, into plasma and your red blood cell. Now, if you don't mix properly, you will pick more of the plasma and less of the red blood cell, and it will affect your result. You will have low result, and you don't want to have false results. So that's why we have to mix very well to ensure that it's the way we collected it from our patient. So once we have ensured that we've mixed very well, we'll place a capillary tube into the blood. Now we are going to fill this capillary tube 3/4. So we are filling the capillary tube to 3/4 of its volume or its size. So we'll fill it 3/4. So you see, this is 3/4 If you divide this thing into 4, you see this is 3/4 the size of this capillary tube. Now you clean with your cotton wool and then get your plasticine. Do not move the blood. Do not move your hand like this for the blood to shift to this side. Ensure that the blood is at the edge of this capillary tube. Do not shift your hand away from the mouth of this capillary tube. Ensure that the blood starts from the beginning of this capillary tube, and then you gently go into your plasticine to seal. The plasticine acts as a sealant. So you see it's sealing this side. You seal properly. If you don't seal well, there will be spillage during spinning. So we see we've sealed very well. To know that you have sealed very well, there is no breakage. Once there is no breakage in the blood, there is no place that there is air bubble. There is no air bubble along the whole blood in this capillary tube. You know you have sealed properly. So there should be no space, no air bubble during filling the capillary tube or sealing. So if you pick air bubble during filling, it will affect. So don't pick air bubble and don't allow space or cuts in between. So this is how you seal. Then we'll go over to spin. Now we spin our filled capillary tube at 12,000 RPM for 5 minutes. And if you are spinning at 15,000 RPM, that's revolution per minute, you spin for 3 minutes. So the higher the revolution per minute, the lower the minute. So because you are spinning at 12,000 RPM, it's going to be for 5 minutes. Now, I will go over to the centrifuge. So I'll show you how to place your capillary tube and how to spin. So this is a haematocrit centrifuge. It's different from the one in our previous video on urine microscopy. Now, this is our haematocrit centrifuge. In our last video, what we saw there was bucket centrifuge. Now, this one is our microhaematocrit centrifuge, used specifically for PCV determination. So to open, you come to the side here. There is a knob. You press the knob to open. Once you press this knob, then you can open. If you don't press the knob, you will not be able to open. See, if you want to open without pressing this knob, it won't open. So you press the knob and then you open. The next, this is the cover. So you open, this is the cover. You open the cover and then you place the filled capillary tube with the side containing the side containing the plasticine should be at the end. Should be at this end, not towards the center. The side containing the plasticine, the edge containing the plasticine should be at the edge, away from the center. So it should be at this end to avoid spillage. Now, this is a centrifuge, so you have to balance the weight. And how do we do that? By putting another tube, another capillary tube at the other side, even if it's empty. Assuming you have 2 PCV to carry out, you can put them at opposite direction. But because we are doing just one, we'll put this empty capillary tube at the opposite direction to balance the weight of the capillary tube in the centrifuge to avoid spoiling our brush or breakage of the capillary tube. Now, after we must have placed this, we close. This is how you close. You place the cover and then you cover it. If you don't put this cover, your capillary tube is going to break and the blood will spill. So you must ensure you put this safety lid. Then you close the centrifuge. Once it's closed, now you're going to check. Okay, we are spinning at 12,000 RPM. We're spinning at 12,000 RPM. 12,000 RPM. This is 12,000. If you watch very well, you see 11,000 RPM is the inner one, which is this. This is 11,000 RPM. You see the instruction? So this one now is 12,000 RPM. So this one like this is 12,000 RPM. If you take it inside, it's 11,000. So once you've placed this like this, you check your time. You put the time. You put it to 5 minutes. Once you put it to 5 minutes, you put it on. You put it on from the socket, and then you put it on as well from this side, and then you start spinning. So after spinning our blood in the centrifuge for 5 minutes, gently open and then bring it out. So this is how it looks after spinning. So this is the plasma part. You see this white part here is called the buffy coat. It contains the white blood cells. It's called the buffy coat. If you look carefully, you see the white part just on top before you have the red cells. So you see the cells are packed. You see where they derive the name from? Packed cells. So you see the cells here are packed. So now, how do we read using our haematocrit centrifuge? Now, you see this part that is movable, you place your capillary tube onto this part that is movable. Now, because no two persons can actually pick the same quantity of blood in a capillary tube, that is why we have this adjuster. You can adjust this to the quantity of blood you picked, because the upper limit of the plasma, the part that has the plasma, must touch this line above. While the last part that has the red blood cell must touch this 0 mark. So while the upper part, this upper part of the plasma will be at the 100 mark, this last part that has the red blood cell should be at the 0 mark. So let me show you what I mean. So you keep adjusting. So you see, the lower part that has the red blood cell, this is where note, you are not measuring the part that has a plasticine. You are starting from where the red blood cell started, just before the plasticine. So you make sure that the part that has the red blood cell just before the plasticine is touching the 0 mark. Okay, we are there now. So you see that the part containing the red blood cell is touching the 0 mark. Now, the part that has the plasma is also at the 100 mark. This is when you know that you have placed your PCV, your capillary tube very well. So now you read. You move, you see this line, this white line from this is how you move it. You place this just under the buffy coat. That's that white line I told you that is for the white blood cell. You place it just under the buffy coat. You are not measuring the buffy coat together with the red blood cell. Remember, it's packed. The red blood cell that is packed that want to check the height. So This is how you do it. So we are just under. So what's the result? This is 35, 36, this is 37. So our PCV result is 37. Our PCV result is 37. Now, this is how to read packed cell volume using the Microhaematocrit reader. In our subsequent class, I'll teach you how to read your packed cell volume using the meter rule. Because this one now, this 37 we got now is going to be in percentage. You know, I told you you can get your result in percentage or in liter per liter. So in our subsequent class, I'll teach you how to get your result in liter per liter using your meter rule. In the event that you don't have the capillary, your Microhaematocrit reader available. So this is how you read. So a person that has, I want you to tell me in the comment section what you think. A patient with this PCV result of 37 and this individual is a male. Is this individual anemic or not anemic? So please tell us in our comment section. Don't forget that the reference range for adult female is 36% to 46%, while the reference range for adult male is 40 to 54%. So tell me in the comment section, do you think this patient is anemic or not anemic? And whatever you say, give your reasons. And if you've watched this video to this point, I want to ask you, why have you not subscribed to our channel? Like, more than half of our viewers are not subscribers. So please and please, I want to encourage you to please click on that subscribe button. Turn on the notification bell so you'll be the first to be notified when we drop another video such as this. And please, you can comment and I'll be there to answer any question you have. Like and share this educative content. Thank you.